Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 24, swap nodes in pairs. This is a medium-level problem, often used in coding interviews, focusing on manipulating linked lists. The goal is simple. Given a linked list, we need to swap every pair of adjacent nodes and return the head of the modified list. So, if we have a list like 1, 2, 3, 4, the output should be 2, 1, 4, 3. Seems straightforward, right? But there are some tricky aspects, especially when dealing with odd-numbered lists or edge cases like empty lists or lists with only one node. We'll explore different approaches and, of course, write the most efficient code. Are you ready to dive in? Let's go! Understanding with examples. Let's solidify our understanding with a few examples. Imagine the input list 1, 2, 3, 4, 5. After swapping pairs, we get 2, 1, 4, 3, 5. Notice how the last node remains unchanged because it doesn't have a pair. Now consider 1, 2, 3, 4. This becomes 2, 1, 4, 3. And finally, an edge case. What if the input is just 1? The output should remain 1. There's nothing to swap. See, even seemingly simple problems can have edge cases that require careful consideration in your code. Let's see how we approach this using different techniques. Brute force approach. One way to solve this would be a brute force approach. We could iterate through the list, swapping pairs one by one. This involves finding the nodes, swapping their values, and updating the pointers. While this works, it's not efficient. We'd have to traverse the list multiple times, leading to a time complexity that's O of n squared, not ideal. It's also relatively complex to implement cleanly, making it error-prone. So, even though it's conceptually easy, the brute force method isn't the best choice for this problem. Instead, let's look at a more elegant and optimized solution. Optimal solution. The optimal solution involves a single pass through the linked list using iterative approach. We'll use 3 pointers: prev, cur, and next. Prev points to the node before the current pair, cur points to the first node in the current pair, and next points to the second node in the current pair. We iterate through the list, swapping cur and next, and then updating the pointers to move to the next pair. This clever pointer manipulation ensures we only traverse the list once, leading to a far more efficient solution. This makes our algorithm incredibly efficient. Code implementation. Let's see the code in Python. We'll define a function, swap pairs, that takes the head of the linked list as input. We'll initialize our pointers and then use a while loop to iterate. Inside the loop, we swap cur and next, update prev, and move cur and next to the next pair. Remember to handle the edge cases, an empty list or a list with only one node. This implementation is concise, readable, and very efficient. I'll leave comments in the code for you to follow along easily. Now let's look at the full implementation. Time and space complexity. Now let's analyze the time and space complexity of our optimal solution. Because we're traversing the linked list only once, our time complexity is a very efficient O of n, where n is the number of nodes. In terms of space complexity, we're only using a constant amount of extra space for our pointers, so our space complexity is O of 1, constant space. This makes our algorithm highly efficient, both in terms of time and space, which is crucial for optimal performance, especially when dealing with large datasets. We've significantly improved on the brute force approach. Engagement break. So, what did you think of that solution? Pretty neat, right? If you found this explanation helpful, please give the video a thumbs up. It really helps the algorithm and keeps the channel growing. And don't forget to subscribe for more LeetCode tutorials and coding interview tips. If you have any questions or alternative solutions, feel free to leave a comment below. I read and respond to every single one. Conclusion. In this video, we tackled the swap nodes in pairs problem, exploring both a brute force approach and a much more efficient optimal solution. We saw how careful pointer manipulation can dramatically improve the performance of our algorithm, achieving O of n time and O of 1 space complexity. This is a classic interview problem